Hey everyone, thank you so much for joining in as part of the 6th open house discussion on the Open Credit Enablement Network. The agenda for today's discussion is to share with you how confidential clean rooms, which is a new technology development that's taken place, allows one to really preserve in a new way, preserve privacy of data, preserve business confidentiality of models, machine learning models, and how it could be used to really accelerate and further the credit democratization efforts that are underway as part of the OCEN system. Before we dive in, to give you a quick overview of iSPIRT, iSPIRT is a nonprofit technology think tank driven by volunteers. We take a long-term view of problems, and the two problems we've picked up are financial and health inclusion. So these are two societal problems that are very important to us. Within financial inclusion, our primary focus is on democratizing credit, and that resulted in building a whole set of digital public infrastructure, various building blocks you may be familiar with, including Account Aggregator, UPI, DigiLocker, eSign, and so on. And so therefore, we see ourselves as taking 20 to 30-year views on these types of problems that often gives us the space and liberty to build this out, much like universities and research labs in the West. Then you have, for example, VCs and policymakers that take an 8 to 10-year view of this. Once they're made aware of what these building blocks are, they help put it into action. And then you really have your startups or your which are challengers or existing enterprises as incumbents, taking 3 to 5 year views of these new playgrounds and really bringing them to life in a highly accelerated manner. So that's where iSPIRT kind of fits in within the ecosystem. And we're driven by no greed, no glory volunteering. So the glory is given to the market players, the entrepreneurs, as they adopt this and make these playgrounds successful. The glory is given to the policymakers as they help in facilitating the adoption of these playgrounds and make it successful. And then the greed is given to the entrepreneurs as they build various companies, very successful companies on top of these playgrounds that emerge. So in today's context, like I said, I'm going to share with you, and along with me, we have Kapil Vaswani, who's another volunteer on this project. And together, we're going to share with you how confidential clean rooms can dramatically widen access to credit in India and what that technology is about. To do that, one must first understand the construct within which it's emerged, which is the data empowerment and protection architecture. As you know from previous iSPIRT open house discussions, DEPA is an architecture that allows individuals and businesses to seek control of their data in a safe, secure manner. And the account aggregator is an initiation of DEPA, instantiation of DEPA for the financial sector. In fact, this recently went live for 300 million bank accounts with the largest private and public sector banks on board as providers of data. And the way it works is the user has a choice. They can go to many account aggregators. These are, like I said, consent managers for their financial data. Today, 4 of them have been licensed by RBI, and many of them, many more have an in-principle approval from the RBI as well. So the user can select whichever one, register, then discover where all their data resides with the financial information providers. These are custodians of the user's data. Data in this architecture is completely decentralized, so it remains at source, and it's only shared in the context of a particular transaction for a particular purpose. And identity as well is federated. So there's no usage of a centralized identity at all to facilitate these transactions. It's up to the user to select that. And in fact, you can have many provider issued IDs, like your bank issued ID or your mutual fund issued ID or your tax issued ID, all of which can be used to create that aggregated and common view by you, the user. So there's no one in the system that has that common/unique view. So the user registers with an account aggregator, discover where their data resides, links their data between the account aggregator and the financial information provider. And once that long-term linkage is established, the user can then go on to share their data with financial information users on the other end. These are essentially companies that are looking to consume users' data and offer them a better service. It might be a lender offering you a loan on the back of your cash flow data. It might be a fintech startup trying to help you manage your money better through a personal finance management application, or maybe an investment or wealth advisory firm that's now building out a wealth manager application to help you with that end-to-end life cycle. So in that context, the user can go to an FIU, as it's termed, share with them their account aggregator ID, which would be, let's say, Siddharth at the rate of AA1 as an example. And then that respective FIU can raise a consent request in real time against Siddharth at AA1. Once that is done, on my account aggregator, I get a notification saying, hey, this FIU is looking for access to your data. Do you authorize it? Yes or no? And if I say yes, my data gets shared electronically. Now, one of the key principles behind this architecture is called organs. And you would have, if you're familiar with the previous DEPA presentations, I won't go into the details of it, but within organs, where O is an open standard, R is revocable, G is granular, and A is auditable, N is notice, S is secure, the G aspect of organs is very important. In our previous presentations on DEPA, when we spoke about granularity, we said there are different ways in which data can be shared. One is where raw data gets shared with the FIU. For example, you're sharing your bank account statement. Those last 12 months bank account statements go technologically to the FIU's environment once you've given consent, which is a predominant way in which data is shared today as well. The second option is a form of query, where let's say the FIU only wanted to know, do you have a minimum asset value greater than 10,000 rupees over the last 6 months? In which case you're only sharing a query or an output of that query, which would be a yes or no response back with the FIU. So this is already more privacy preserving because now the FIU, rather than getting access to the entire bank statement, is only getting access to a subset of it. But this doesn't scale well from a computation perspective because all of it will have to be defined in some form of standardized query languages. So it has its limitations. And therefore, that's where the third type of data access, which so far we've often referred to it as virtual data rooms. The idea where instead of data being sent to the code, to the models, can you bring data into this privacy preserving environment? And can the FIU submit their code to this privacy preserving environment as well? And therefore the code computes on the data in this environment and only the insights get taken out. And so for a long while, we termed this as VDR or virtual data rooms. And now for the first time, we believe the technology has become available and over the next few years will become available at scale as a commodity to make this happen. And those are called confidential clean rooms, which Kapil will talk about. How does that fit into the larger account aggregator and OCEN ecosystem? So again, there are a whole set of open house discussions that do a deep dive on what is OCEN, the way it works, and so on. I will give a quick overview, but my request is if you have any questions to really go back and watch the previous OCEN open house discussions. The way OCEN works is you have on one end lenders and on the other end borrowers, which are potential borrowers, which might be MSMEs or individuals interacting with each other through some marketplace of sort, which are called loan service providers. Now, the question for us was, how do we bridge between the two? How do we bridge low cost of capital that the lenders have with low cost of customer acquisition, given that these LSPs have ready pool of customers? For example, it may have a pool of 1 million MSME restaurants, or it may have a pool of a couple of 100,000 MSMEs that are supplying to government agencies and so on. And so that's where the Open Credit Enablement Network comes in, because it defines a set of open protocols that allows the lenders to interact with these LSPs and hence the end customers to flow credit to them. So this includes managing the entire life cycle of a loan, right from application to offer generation, to agreeing to the loan and its signing, to then even going on to setting up mandates and various collection recovery mechanisms, and then finally with repayment as well. This is currently live for Sahai Gems, which is the government e-marketplace, and over a period of time, you'll see new LSPs come on board. Now, within OCEN, one of the components which is brought in is the account aggregators, because for the lenders, they need the ability to receive access to the borrower's data to inform and return back that real-time offer. Now, when that happens, two problems come up. One, the first problem is when my data gets shared in the old world, I would typically go to, let's say, one lender that I trusted. Maybe they had a physical bank branch next to me, and I would apply. So in which case, my data of my very sensitive information, like my bank account statements and my credit bureau records, would get shared only with that lender. If they rejected me, maybe I wouldn't do anything, or maybe maximum I would walk and go to the second lender, but that's about it. Within OCEN, when you widen the net to multiple lenders, and over a period of time, you can expect 10 and 20, 50, maybe even 100 lenders on board within the OCEN construct. A key element is how do you ensure that privacy of users' data is maintained? Now, within the consent system, of course, every time data is shared, you have a consent artifact attached to that. And therefore, the lender, which is a regulated entity at this point in time, either a bank or an NBFC, both of which are regulated by RBI, the lender is responsible and accountable to ensure that they use data only in accordance with that purpose and nothing else. In this case, the purpose would be a loan offer, because I may get 40 loan offers and I may choose one, but my data has been shared with those 40 lenders as well, although I'm starting a relationship with only one of them. So what happens to those remaining 39? The current way to ensure that privacy, like I said, is only through the consent artifact, which I would say is if you look at it from a data governance standpoint, and you look at the world globally from a data governance standpoint, you could think of it as three phases. So the first phase is where there were no rules. Data was shared behind our back, almost in a bilateral manner. Companies deciding on our behalfs what is good and bad for us. And we've seen how that plays out to fairly disastrous effects. Phase two of data governance is where attached to every data flow is a consent request, which was shown to the user and approved in an informed manner by that user, dictating how the data can be used, how long it can be stored, etc. However, that relies on institutional trust. So that means it relies on the fact that you have a layer of regulations. In the financial sector, there are data privacy and data protection regulations, or a country may have a larger act that they've passed through their respective parliament or legislator to preserve users' privacy. And failure in whenever privacy harms takes place, a user will have to go and appeal it through an appropriate court of law. Now, we know that at scale, that system may not work. And as a result, can we move from a paradigm of institutional trust towards trust in code, which is a phase three of data governance? And our view is over the long term, this is the direction that the world will shift to. And that's where the confidential clean rooms comes in. Because as an example, now as part of the OCEN system, rather than my data going into the environments of these 50 lenders, and then us further increasing the need for more supervisory sort of actions by the regulator as well, which just intensifies as data multiplies. And it's very difficult to truly operationalize at scale. you now have the ability to create a system where users' personal data get shared into this environment, and you have clear, in fact, mathematical guarantees of privacy that the privacy of that personal data will be preserved, which would be, let's say, my very granular bank statements and GST taxation records. At the same time, lenders are often concerned about the confidentiality of their model. And they are often very averse to putting their model out externally because they fear that confidentiality may be leaked. And so in this system, you again have guarantees to ensure that the confidentiality, the business confidentiality of their models will not be leaked, and hence they can safely and securely submit those models to this environment. And at the end of it, the output, when the models are applied onto users' personal data, the output being an offer of sorts that then gets returned. And so now for the first time, through this architecture, individuals and their concerns get satisfied through code, and lenders and their concerns also get satisfied through code. And both of them are able to participate in the ecosystem, receive offers from many more lenders. Instead of 100, it could be 200 and 500 tomorrow. Yet the user, because it's often in the case of individuals and even in MSMEs, this is highly, highly sensitive data. If leaked, it can actually have disastrous consequences for these businesses through loss of suppliers, loss of customers, and so on. And so I think this component becomes extremely important. So to do a deep dive into what are CCRs, I've given you an overview of the account aggregator ecosystem, an application of the account aggregator ecosystem for lending, and hence an area or a problem area within which CCRs become extremely important. I'd now like to call Kapil Vaswani, who's a volunteer on this project, to talk a bit about what are CCRs, how do they work, how does that ecosystem look like, and other aspects around, as this is being piloted, how you could participate in this early infrastructure that's being created. And by doing so, go on to create a lot of value and capture value in the long term. So over to you, Kapil.
Thank you. Morning, everyone, and thank you, Sid, for the really nice introduction. So as Sid mentioned, the DEPA and the Account Aggregator framework are really designed to empower individuals and businesses by enabling them to share their own data in a low cost and a frictionless manner, with, of course, their consent. However, as Sid was describing, this reduced friction brings about its own set of challenges, and security and privacy is definitely one of the main challenges. And as the scope of DEPA expands to cover more and more personal data, things like GST statements, health records, telecom data, and as the number of data consumers increase, as adoption of the framework increases, these concerns become even more critical. So, for example, with OCEN, your data can be shared, of course, with your consent, with potentially tens of hundreds of lenders. And today we have no technical guardrails, no technical measures to ensure that every single one of these lenders will use this data only for the purpose you state in your consent. And that, for example, in OCEN is the purpose for evaluating a loan application. And the way we address this is through law. So the draft PDP bill is coming up, which essentially is going to define best practices for data consumers through regulation, through compliance, and then audit. Now, but this is quite a high bar for a large number of ecosystem partners, smaller lenders, new age startups, whose participation we think is quite critical to the long-term success of this ecosystem. So another challenge in this space is that we've identified is that it's actually quite challenging today for data consumers to have access to high quality training data that helps data consumers train better models. Now, making sort of democratizing access to training data is quite challenging for multiple reasons. First and foremost, there is no strong incentive for you and me to share our data for training today because it doesn't directly benefit us. Unlike the regular sort of lending flow where we are expecting a service in return. And secondly, for training, you often need large amounts of data to be collected and labeled over a long period of time, all of which significantly increases privacy risks. So to address both of these concerns, we have been thinking about a new construct, a new technical construct in DEPA called confidential clean rooms. So confidential clean room is a secure, protected environment that can be set up by the data consumer or by a TSP or by a cloud provider, where sensitive data from multiple data providers can be processed while limiting the purpose for which it is being processed. So essentially, you can think of a clean room as an environment that allows sensitive data to be processed while only revealing the final outcome or the decisions to the data consumer. In the lending case, for example, the clean room can process sensitive financial data. The data consumer can run their own business rule engine on all of that data. And the clean room will enforce that only the final loan offer is revealed to the data consumer, and the rest of their personal data stays only within the confines of the clean room and is never available to the data consumer in raw form. And at the same time, the data consumers' code and models remain protected even from the platform that is hosting the clean room. And what is perhaps more important and interesting about the way we are thinking about clean rooms is that data consumers can now give a technical proof to any external entity like an end user or a regulator or an auditor that the data that they are going to receive is going to be processed within a clean room environment. And this is not a process-based guarantee. It doesn't rely on external audit. It's a technical guarantee that you can give to anyone, any relying party, proving that the data they are going to receive is going to be processed in this environment. And our hope is that this sort of ability to technically prove some properties about your service will significantly reduce operational costs, compliance costs, and make it really easy to operationalize a compliant system. So now we believe that there will be potentially many implementations of this concept of a clean room. And we are actually working to define the standards and the minimum security guarantees we think any clean room implementation must provide. But the reference implementation of clean room that we are building and proposing is based on this idea of confidential computing. So confidential computing is a relatively new hardware-based security primitive that is designed to protect data not just at rest and in transit, which is something we are all very familiar with, but also to protect data in use. So let me take a quick minute to do a quick introduction to confidential computing. So at the core, confidential computing is about two new capabilities that modern hardware is going to provide. The first is the ability to create these, so data consumers, they get this new ability to create a secure environment where they can deploy applications such as containers and run them in isolation from all external access. This includes access from the data consumer themselves. After this setup, the environment is protected even from the data consumer, and from cloud administrators, rogue insiders, and potentially even attackers who may exploit 0 days in privileged software such as the operating system. So you can really think of this secure environment as a hardware protected black box where encrypted data goes in and encrypted results can come out. But the rest of the computation remains a black box for anyone outside that clean room environment. And the second most important feature is that these environments, as I mentioned, are remotely verifiable. So the hardware in this case is going to be capable of issuing certificates to every such environment. And it does that using keys that are only available within the hardware and provisioned securely during the manufacturing. And these certificates can be used to prove to anyone outside that this application hosted in a clean room environment is in fact protected by the hardware. And you can do that even before the end user decides to share their data with this application. So what this means is that as a data consumer, you can now prove to a data principal or to an end user that their application is hosted in this clean room environment. And after obtaining and verifying this proof, end users can now share this data with a specific application for a specific purpose. and not with an individual or an organization like Siddharth was mentioning. So we are moving away from this notion of trusting individuals or organizations to a notion of trusting just specific pieces of code. Right. And so this gives you a lot more control, more granular control over what happens to your data after it is shared. And as you can imagine, this level of control to what happens to your own data is quite a powerful mechanism. Now, confidential computing is already supported by most modern CPUs, including those from Intel and AMD. And they are also supported, the primitive is supported by multiple cloud platforms such as Azure, GCP, and AWS, where you can already allocate confidential computing enabled virtual machines and run workloads like containers. Now, of course, this is still early days. There's more work needed to make this concept more standardized, more push button, more developer friendly. But there is broad agreement in the tech industry that confidential computing is going to be quite a critical tool for data protection in the future, especially as we see regulation and compliance requirements becoming more and more stricter and stronger over time. And really the question we are asking at iSPIRT is, how do we integrate and shape this technology for the benefit of everyone in the DEPA ecosystem? Right. So a lot of the work that is happening today in this ecosystem is being driven by a confidential computing consortium. As you can see, many of the leading tech industries and new age startups are participating to sort of shape how confidential computing evolves. So to evaluate feasibility and value of this clean room concept in the context of DEPA, and in particular, specifically in the context of Open, we are proposing to run a pilot as part of the GST Sahay application, which targets flow-based or invoice-based lending scenarios. So GST Sahay is the first instance, one of the first instances of the Open framework, where MSMEs can get access to credit by sharing their GST filing history and their bank statements to lenders, and then get loan offers in response. But obviously, as we just discussed, this exposes all of the MSME data to lenders, including those whose loan offers that the MSME does not accept. So what we want to do in this pilot is we want to run a scenario where we will have a lender deploy their underwriting models in a confidential clean room, where this sensitive data belonging to the MSME, along with any additional data that the lender may have, maybe through the LSP, can be processed, and a loan offer can be generated without the lender getting unrestricted access to the GST and the raw GST and bank statement data. Now, for lenders who don't have an underwriting model that they can consume, that can consume this data, iSPIRT will provide an initial underwriting model for bootstrapping, mostly for use as a reference. And our hope is that with this pilot, we will understand what it takes to operationalize clean rooms in a real scenario, address requirements such as ease of deployment, certification, auditability, dispute resolution, and all of those sort of core aspects of an end-to-end functioning system. Now, this pilot, of course, needs many organizations to come together. We definitely need lenders who are going to provide underwriting models. We will also need ISVs who have capabilities to pre-process data into a form that the underwriting models can consume. As I mentioned earlier, iSPIRT is going to provide a model to bootstrap if the lender doesn't already have one, which the lender can refine. Microsoft is going to provide the core clean room infrastructure. We will do all of this work in the open source. But critically, we also envisage the role of a TSP who can put all of these components together, own the deployment, and own the deployment in the GST Sahay context. So this is where we are looking for Wave Zero partners to partner with you and take this pilot forward. So where we think there is a lot of value to be a Wave Zero TSP partner, it's a real opportunity. We are expecting that we will have TSPs demonstrate interest by in a couple of weeks from now. We will post a link where you can register your interest in a subsequent blog post. iSPIRT will select roughly 2 or 3 Wave Zero partners towards the end of October, and we will start work with those partners starting towards the end of the year. But from a TSP perspective, the criteria we are looking for is that we are looking for someone where we have strong commitment from the senior management to work on a concept that is still coming up, right? It's still an upcoming concept, still new technology. So we are looking for strong management commitment to work on such technology. We are looking for TSPs who are open and willing to work on cutting edge technology, and who are willing to commit some dedicated time for a period of 6 months starting at the end of the year. And where we see a lot of value for TSPs is that this is really a very small investment from a TSP perspective, but it's quite strategic, because we think that once you have these invested in confidential clean rooms as a service, you can offer this to many partners in this ecosystem, and not just in the financial ecosystem. You can expand this to other use cases such as healthcare and advertising, where privacy is becoming increasingly quite a central topic. You also get to work with us and build expertise and even shape some of this upcoming technology. There's a lot of discussion we are having on how this technology fits end to end, and we are in position to shape how the technology evolves. And of course, there is a global opportunity here. This notion of clean rooms is not just restricted to DEPA. It applies more globally, and not just in the India context. So this is really a rare first mover opportunity for TSPs from India to shape how this space evolves in the future. So I'll leave this with a number of links that you can use to get information about confidential computing and about some of the hardware technology behind this, and how cloud providers are offering this technology. But feel free to reach out to us if you have more questions. And as I mentioned, we will share a link where you can register interest to participate in this pilot. And we really look forward to working with you and shape how this technology evolves.